In 1850, a man asked the German Navy to build something with no engine, no precedent, and no working example anywhere on Earth. A ship that could sink itself on purpose, walk along the floor of a harbor, and come back up alive. I was not a naval architect. He was not an engineer by trade. He was a cavalry soldier who had never built a boat in his life. His solution was almost insultingly simple. No propeller, no ballast tanks, no complicated machinery, just a single iron weight, sliding back and forth inside an iron shell, using nothing but gravity to control life and death underwater. That same idea would nearly kill him. It would trap 3 men at the bottom of a harbor for 6 hours, breathing air that was slowly running out. And decades later, it would turn his sunken failure into the oldest submarine on Earth. Why would anyone trust their life to a machine this primitive? His name was Wilhelm Bauer. This is the story of the first military submarine in German history, and the 6 hours that decided whether it would be remembered as a breakthrough or a coffin. Wilhelm Bauer was born in December 1822 in the small Bavarian town of Dillingen on the Danube. His father was a sergeant in a Bavarian cavalry regiment, and there was no family fortune waiting for him, no engineering pedigree, no university path laid out. As a young man, Bauer apprenticed as a wood-turner, a craft of lathes and hand tools, not blueprints. When that apprenticeship ended, he did what was expected of a soldier's son. He joined the army. He rose through the ranks not as an officer, but as an artillery engineer, a technical soldier working with cannons and mechanisms rather than commanding men. It was a low rank. And it would matter later, because when Bauer eventually needed the German military to listen to him, he had almost no authority to make them. In 1848, the war that would change his life began. Denmark and the German states went to war over Schleswig-Holstein, and Bauer found himself stationed on a coastline that Danish warships were choking off almost at will. He watched merchant traffic strangled, watched supply lines cut, watched a modern army rendered helpless by a fleet it could not fight on the surface. The lesson was not abstract. It was sitting in the harbor in front of him. Bauer decided the problem wasn't the size of the German Navy. It was the water itself. If a ship could not survive on the surface against a blockade, then the solution was to stop fighting on the surface altogether. He had no formal training to draw on, so he built his own. He taught himself hydraulics. He taught himself the basic principles of ship construction, reading and reasoning his way through problems that trained naval engineers spent years studying in academies he would never attend. And then he did something almost nobody else building underwater vessels at the time had thought to do. He watched animals. Seals, specifically. Bauer spent hours observing how they dove. Not violently, not mechanically, but by controlling their own body position, shifting out their weight to glide down and rise again with almost no effort. There was no engine inside a seal. There was no pump. There was only balance. That observation became his entire design philosophy. Where other inventors of the era were racing to build complicated ballast systems, tanks that flooded with water and had to be pumped dry again, valves and mechanisms that could fail in a dozen different ways, Bauer stripped the problem down to its simplest possible form. Instead of filling and emptying tanks, his submarine would carry a heavy iron weight on a track inside the hull, slide the weight toward the bow, and the nose would tip down, carrying the vessel into a dive. Slide it toward the stern, and the vessel would rest. No engine, no pump, nothing that could clog, flood, or break down at the one moment it absolutely could not fail. It was elegant. It was cheap. And it asked for almost nothing from the industrial base of a small German state that had no submarine industry to speak of, because it needed almost nothing to work. Bauer called his creation the Brandtaucher, the fire diver. And in his mind, the principle behind it was simple enough to say in a single sentence: control the depths not with machinery, but with gravity itself. He was about to find out that gravity does not forgive mistakes. Bauer's idea might have stayed a soldier's daydream if it hadn't landed on the desk of the right man. His early sketches for an underwater vessel capable of slipping beneath the Danish blockade caught the attention of Schleswig-Holstein's Minister of Marine. the one official with both the authority and the motive to take a low-ranking artillery engineer seriously. The blockade was strangling the coast, and here was a soldier promising a way around it, not through more ships, but underneath the ones already there. The minister didn't hand Bauer a shipyard. He gave him something smaller and far more reasonable: permission to prove it first. Bauer was authorized to build a model, barely the size of a shoebox, 28 inches long, 7 inches wide, 11 inches deep. It was less a submarine than a test of an idea, and everything that came next depended on whether that idea held water, literally, in front of an audience that had the power to end the project on the spot. The demonstration took place in Kiel Harbor, before a gathering of naval officers and dignitaries who had seen plenty of inventors with plenty of promises. Bauer's little iron model dove, held its position, and surfaced again, exactly as he said it would. There was no trick to it and no need for one. The mechanism was simple enough to understand just by watching it work. Shift the weight, and the model tips and dives. Shift it back, and it rises. For men used to evaluating ships by size and firepower, watching a design win an argument through sheer mechanical honesty must have been almost disarming. The model succeeded. Now for a moment it looked like Bauer had what every uncredentialed inventor needs most: official belief. The full-scale vessel was approved. Soldiers of the Schleswig-Holstein Army, and ordinary civilians along the coast, people with no stake in naval engineering beyond wanting the blockade broken, put money toward the project. It was, in the truest sense, a submarine funded by the people it was meant to protect. But approval and funding are not the same thing, and Bauer was about to learn the difference the hard way. The official requirement was ambitious on paper: a vessel that could dive to roughly 100 feet, approach an enemy warship completely undetected, fix an explosive charge to its hull using a diver's glove built into the side of the craft, and slip away before the mine detonated. At that depth, with that mission, the Brandtaucher would have been a genuinely formidable weapon, capable of threatening a fleet that had never had to worry about an attack from directly beneath it. The money to build that vessel never fully arrived. Contributions from soldiers and townspeople could cover a project. They could not cover the project as originally designed. And so, piece by piece, the Brandtaucher was quietly cut down to fit the budget instead of the mission. The most dramatic casualty was depth. The 100-foot dive target Bauer had promised the Minister of Marine was reduced to roughly 30 feet, less than a third of the original specification, and nowhere near enough to operate with true stealth beneath a blockading fleet. Then came a change that mattered even more than the depth. Bauer's original design called for proper ballast tanks, sealed compartments that could be flooded and pumped dry to control buoyancy. The same basic principle every submarine in the world would eventually use. Ballast tanks cost money and required precision engineering that the shrinking budget simply couldn't support. So the tanks were eliminated. In their place went something far cruder. Seawater would be allowed to pool loose inside the bottom of the hull itself, sloshing and shifting as the vessel moved, controlled only by that same slitting iron weight Bauer had built his entire philosophy around. It was, in a strange way, the purest version of his own idea taken to its limit. Depth and buoyancy controlled by nothing but gravity and a moving mass of iron. But a philosophy that looks elegant in a shoebox-sized model behaves very differently when the thing sliding around is thousands of pounds of loose water inside a full-sized iron hull. Bauer was not the only man in the world chasing this idea. Across the Atlantic, engineers in the American South were quietly working through the same basic problem: how to attack an enemy fleet from underneath the surface entirely. A pursuit that would eventually produce a vessel called the Hunley. Neither man knew of the other's work. Both were reaching, independently, for the same impossible goal: to make the ocean itself into a weapon. Bauer simply got there first. Construction began at the iron works of Schwefel and Hault in Kiel, under the direction of engineer August Hault. By December of 1850, the Brandtaucher was finished. 28 feet long, weighing roughly 70,000 pounds, built not to the specification that had won it approval, but to the compromise that budget and bureaucracy had forced onto Bauer's original vision. He had won his submarine. What he had not yet learned was that every cut made to pay for it was about to be tested at the bottom of Kiel Harbor, in front of the very men who needed to believe in him. By December of 1850, word had spread through Kiel that Bauer's submarine was finished. This was not a private engineering trial tucked away from public view. It was, in every sense that mattered to the people who had funded it, a public event. Soldiers who had donated a portion of their pay, townspeople who had handed over what they could spare, all of them waiting to see whether their money had bought a genuine weapon or an expensive iron coffin. The expectations riding on the Brandtaucher were enormous, and they went well beyond curiosity. Denmark's navy still held the coast in a chokehold, and for a population that had spent months watching that blockade squeeze the life out of their trade and their supply lines, Bauer's strange invention had become something close to a symbol of hope. If it worked, it wasn't just a technical curiosity. It was a vessel that could slip beneath an enemy fleet no German ship could challenge on the surface, and strike at exactly the moment and place the enemy least expected it. People did not fund the Brandtaucher because they understood hydraulics. They funded it because they had run out of other options. The vessel itself gave little outward sign of the ambition packed into it. 28 feet of riveted iron, blunt and unglamorous, sitting low in the water at Kiel Harbor. Inside, propulsion came from nothing more sophisticated than two crewmen turning a large treadwheel by hand and foot, driving a crude propeller through sheer physical effort. A third man, the captain, stood at the stern, working the rudder and, when the moment came, reaching through a rubber glove sealed into the hull to arm a mine against an enemy ship's hull from the inside of his own vessel. It was a design that asked ordinary men to power a war machine with their own legs, and to trust an iron shell around them not to give way under the sea. On February 1, 1851, that trust was put to the test in front of an audience. Bauer descended into the Brandtaucher alongside two other men, Friedrich Witt, a carpenter, and Wilhelm Thomson, a blacksmith. Neither man was a professional sailor. Neither had any special training in underwater operations. They were tradesmen who had agreed to climb into an unproven machine because Wilhelm Bauer, a cavalry soldier with no engineering degree, had convinced them it would work. The hatch was sealed. On the surface, naval officers and dignitaries, who had every reason to be skeptical, stood watching the water, whereas for moments earlier, 3 men and an iron hull had been visible above the waterline. For the first few minutes, everything went exactly as promised. The Brandtaucher began its descent smoothly, the sliding weight doing precisely what Bauer had designed it to do, tilting the vessel gently downward as it eased beneath the surface. To the men watching from the dock, it must have looked, for just a moment, like the future of naval warfare quietly disappearing beneath the harbor. Then the compromises made months earlier to save money started to matter. As the Brandtaucher continued its descent toward the deepest part of the harbor, the vessel began to tilt sharply by the stern. The same loose, unsealed water that had replaced Bauer's original ballast tank is now shifting unpredictably inside the hull, throwing off the careful balance the entire design depended on. The hull itself, thinned to less than half its intended thickness to cut costs, began to strain and crack under water pressure. It was never built to withstand at full specification. The pumps meant to manage water inside the vessel proved too weak for what was now flooding in. The propeller wheel, driven by 2 men who could feel the situation turning against them with every stroke, was damaged as the vessel began to keel over entirely. Slowly, without any dramatic final lurch, the Brandtaucher settled onto the floor of Kiel Harbor. Above the surface, there was nothing left to see. No hull. No bubbles breaking the water in any reassuring pattern. To the crowd on the dock, the submarine that had been promised as Germany's answer to the Danish blockade had simply vanished, and there was no way to know from where they stood whether the 3 men inside it were already dead. Inside the hull, the men trapped on the floor of Kiel Harbor now had time to understand exactly why they were there. The vessel that had carried them down was not sinking because of some unforeseeable accident of the sea. It was sinking because of decisions made months earlier. At a desk, far from any water at all, Bauer's original design had called for sealed ballast tanks, compartments that could be flooded and pumped dry with precision, giving a crew fine control over depth without ever putting the integrity of the hull itself at risk. That version of the Brandtaucher never got built. When the promised funding fell short, the tanks were the first thing cut, replaced with loose water sloshing freely inside the hull, controlled only by Bauer's sliding iron weight. It was the same philosophy that had made his invention possible in the first place. Simplicity instead of complexity, gravity instead of machinery, pushed past the point where it could still be trusted. A model the size of a shoebox could get away with crude mechanics. A 28-foot vessel carrying 3 men could not. The hull itself told the same story. Bauer had designed the Brandtaucher's iron plating to a thickness that could withstand real depth, real pressure, a real dive to the 100-foot target the Minister of Marine had originally approved. What actually went into the water was built to less than half that specification, thinned out plate by plate to fit a budget that had shrunk every time the project changed hands. At shallow depth, the difference might never have been tested. At the bottom of Kiel Harbor, with the stern tilted down and the hull straining under water pressure, it was never meant to survive. That difference was the reason the walls had begun to crack in the first place. None of this had been hidden from Bauer. He understood, better than anyone standing on the dock above him, exactly what each cut had cost his design. He had watched a submarine capable of a genuine 100-foot combat dive get quietly reduced, decision by bureaucratic decision, into something closer to a fragile proof of concept. And he had climbed inside it anyway, because a proof of concept that never dove at all would have ended the project just as surely as a failure. The men who controlled the money had never set out to sabotage him. They had simply treated a war-winning weapon as a line item, trimming it the same way they might trim a budget for uniforms or horses, without fully grasping that a submarine has no margin for half measures. A cannon that is undersized still fires. A submarine hull that is undersized simply fills, all at once, at the exact depth where failure is least survivable. And the world was not waiting for Bauer to get it right. On the other side of the Atlantic, engineers working through the same basic problem, how to strike an enemy fleet from beneath the surface where no gun could answer back, were pursuing their own answer to the same question, work that would eventually produce the submarine Hunley. Bauer had no way of knowing this as he sat on the floor of Kiel Harbor. But the race to put the first genuinely effective military submarine into the water was not a race with only one runner. And every hour the Brandtaucher spent broken and useless at the bottom of a German harbor was an hour in which that race continued without him. Inside the hull, none of that mattered yet. What mattered was the air. 3 men were sealed inside an iron shell that had just proven, in the most literal way possible, that it could not be trusted at depth. The hatch that had sealed cleanly on the surface was now jammed by the water pressure pressing in from outside. A door that would not open no matter how hard 3 frightened men pushed against it. Above them, on the dock, officials and townspeople who had funded this vessel with their own money could see nothing but flat water, where a submarine had been minutes before. There was no way to signal them. No way to know if anyone above even understood the men were still alive. Bauer had built his invention around a single, elegant idea, that gravity, not machinery, could be trusted to move a vessel safely through the water. He was about to find out whether that same principle, twisted by circumstance, could also be trusted to get 3 men back out alive. 28 feet below the surface, in total darkness broken only by whatever thin light could reach through the murk of Kiel Harbor, 3 men understood they were now fighting a different battle than the one they had trained for. The dive had failed. The hull had settled onto the harbor floor, tilted and half flooded, and the hatch above them refused to move no matter how hard they threw their weight against it. Water pressure was the enemy now, and it was patient. Outside the hull, the sea pressed inward with a force that made the hatch feel welded shut. Inside, the air the 3 men breathed was finite, and every minute they spent working out a solution was a minute that air supply quietly ran down. Bauer had never trained for this exact situation, because no one in the world had. There was no manual for surviving inside a sunken submarine, because before this afternoon, surviving inside a sunken submarine had never been done. What Bauer had instead was the same instinct that had gotten him this far in the first place, an engineer's habit of looking for the physics hiding inside a problem, rather than simply pushing harder against it. The insight came from the trapped water itself, the same loose ballast that had doomed the dive in the first place. If they let more water into the hull rather than fighting to keep it out, the air trapped inside the compartment would be forced into a smaller and smaller space. Compress that air enough, and its pressure would begin to match the crushing pressure of the sea outside the hatch. Match that pressure exactly, and the hatch would no longer be sealed shut by a force pushing against it from one side alone. It would simply open. It was a desperate answer, and a dangerous one. Deliberately flooding a compartment that was already trapping 3 men underwater meant trusting that they could open the hatch and reach the surface before the rising water became the very thing that killed them instead. There was no way to test the idea first. There was only one chance to be right. So Bauer and his 2 companions did the only thing left to do. They opened valves and let the sea in. Water rose around their legs, then their waists, cold and unrelenting, filling the iron shell that was supposed to have kept it out. Every inch the water climbed was an inch closer to drowning, and an inch closer to the pressure inside the hull finally matching the pressure holding the hatch shut. There was no way to measure that balance from the inside. There was only the sound of water rising, and the growing crush of air compressing around 3 men who had no choice now but to wait it out, breath by breath, in the dark. 6 hours passed this way. 6 hours of cold water climbing steadily around them, of air growing thinner and more compressed with every passing minute, of 3 men with no training for this exact crisis trusting a piece of physics that had never been tested by anyone, anywhere, in exactly these conditions. Above them, on the dock, the crowd that had gathered to watch history be made had no way of knowing whether they were witnessing a triumph still unfolding or a tragedy already finished. There was nothing to see from the surface but flat water, where a submarine used to be. At the 6-hour mark, with water risen high inside the hull, and the pressure inside the compartment finally equal to the crushing weight of the sea outside, Bauer reached for the hatch one more time. This time, it gave. Bauer, Witt, and Thompson forced their way out of the flooded hull and swam upward through the cold, murky water of Kiel Harbor, breaking the surface in front of a crowd that had spent 6 hours believing they might already be dead. There was no cheering fanfare waiting for them, no immediate parade. There was simply the sight of 3 exhausted, half-frozen men alive in the water, having done something no submariner in history had ever survived before them. What happened in that harbor on February 1, 1851, would later be recognized as the first submarine escape in history, to be witnessed and formally reported. An accidental milestone born not from careful planning, but from 3 men refusing to die quietly in the dark. Bauer had not set out to make history with an escape. He had set out to make history with a working weapon. Instead, the moment the world would remember first was the moment his invention nearly killed him, and the improvised, physics-driven instinct that got him out alive. The Brandtaucher itself did not come up with them. It remained where it had settled, 28 feet down on the floor of Kiel Harbor, an iron hull full of seawater, an unrealized ambition, abandoned at the exact depth. Its own thinned-out walls had failed to survive. Bauer had walked away from his own invention alive. What he did not yet know, standing dripping on the dock in the aftermath, was that surviving the Brandtaucher would turn out to be easier than surviving what came next. The applause that should have followed a submarine crew's safe return never quite arrived. What Bauer and his 2 companions had survived was remarkable, but survival wasn't what the government of Schleswig-Holstein had paid for. They had funded a weapon meant to break a naval blockade, and what they got instead was a wrecked hull sitting on the floor of Kiel Harbor, and a project that had nearly killed the 3 men who believed in it most. The reaction was swift and unambiguous. The government that had approved Bauer's model, funded his full-scale vessel, and watched it sink in front of a public crowd wanted nothing more to do with submarines. Further support was refused outright. There would be no second Brandtaucher built in Schleswig-Holstein, no repaired version, no second chance on the coast where it had all begun. Bauer, a low-ranking soldier with no formal engineering credentials to fall back on, found himself without a military, without a shipyard, and without the one thing every inventor needs most after a public failure: someone still willing to write a check. He did not stay in Schleswig-Holstein to argue the point. He left, carrying his designs and his conviction that the underlying idea was sound, even if this first attempt at building it had not been. What followed was less a triumphant second act than a long, grinding tour of rejection. Bauer pitched his submarine to Austria. He pitched it to England, where he briefly caught the interest of the prince consort before the enthusiasm faded into nothing concrete. He pitched it to France. Each government listened politely to a Bavarian ex-soldier explain how a sunken submarine represented the future of naval warfare. And each government, in its own way, said no. For a man who had already watched his life's work sink to the bottom of a harbor once, this second wave of rejection might easily have been the end of the story. Instead, Bauer did something that turned out to matter almost as much as the Brandtaucher itself. He found a different use for the exact expertise his failure had given him. Nobody in Europe understood the physics of a sunken hull, water pressure, and underwater salvage quite the way Wilhelm Bauer now did, because nobody else had spent 6 hours living inside the problem. He began taking on salvage work, applying the same hard-won instincts that had gotten him out of the Brandtaucher to the business of raising other people's wrecks. His reputation in this new, unglamorous field grew largely on the strength of one particular job, the successful recovery of a sunken vessel called the Ludwig, a salvage operation that put his name back in front of people who mattered. Not as the man whose submarine had failed, but as the man who understood the seafloor better than almost anyone alive. It was this reputation as much as the original submarine idea that finally opened a door no government in Western Europe had been willing to open. In 1855, Bauer secured a contract in Russia, working under the patronage of the imperial court in St. Petersburg. There, with funding that Schleswig-Holstein had never been able to provide, he built a second submarine, the Sea Teufel, the Sea Devil, a larger vessel that incorporated a hard lesson learned at the bottom of Kiel Harbor. This time, Bauer included a diver's airlock chamber built directly into the hull, a compartment that would allow crew members to leave and re-enter the submerged vessel safely, a design detail that existed for exactly one reason. He had spent 6 hours learning what happens when a submarine hull offers no way out. The Brandtaucher had cost Wilhelm Bauer his standing in Germany, his government's confidence, and very nearly his life. What it had not cost him was the underlying conviction that had gotten him into an untested iron shell in the first place, somewhere between the sunken hull in Kiel Harbor and a new keel being laid in St. Petersburg. Bauer had proven something that no government rejection could take away from him. The idea itself had never been the failure. Only the money behind it had been. Russia gave Wilhelm Bauer something no German state ever had: a full budget and a government willing to let him build his submarine the way he had originally envisioned it, rather than the way a shrinking treasury forced him to. The Sea Teufel was completed in St. Petersburg with the backing of the imperial court, and by most accounts it performed well, diving and surfacing without the catastrophic structural failures that had doomed the Brandtaucher. For a brief period, it looked as though Bauer's long exile through the rejected proposals of Europe had finally ended in vindication. It did not last. Detailed records of the Sea Teufel's later service are thin, and what survives suggests a project that faded rather than triumphed, quietly retired without the dramatic combat use Bauer had once imagined for his original design. There was no naval battle won beneath the waves, no blockade broken by an underwater strike. The vessel that was meant to prove Bauer's ideas on the largest stage available to him instead became another chapter in a career defined less by decisive victory than by persistence in the face of one disappointment after another. Bauer's later years followed a similar pattern of motion without resolution. He returned briefly to Prussian service, a state that had shown a little interest in his submarine work years earlier, then found himself back in his native Bavaria, still experimenting, still chasing the underwater ideas that had defined his entire adult life. He conducted underwater shooting experiments on Lake Starnberg, testing whether weapons could be fired effectively from beneath the surface. He worked on methods for laying cable underwater, applying his hard-earned knowledge of pressure and depth to a problem with obvious commercial and military value. In an age when telegraph lines were beginning to stretch across seas, none of these later projects produced the singular breakthrough the Brandtaucher had once promised. They were the work of a man still convinced that the ocean floor held answers worth pursuing, even after the world had largely stopped listening. Health problems compounded the difficulty of these final years, wearing down a man who had already survived what few engineers of his era ever had to survive. Wilhelm Bauer died in Munich on June 20th, 1875, at the age of 52. He died as a far-traveled inventor whose name was known in naval circles across 3 empires, but not as a man who had ever seen his original vision fully realized. No German navy had adopted his submarine. No decisive victory bore his name. What he left behind was not a fleet, but an idea, and a hull still sitting on the bottom of Kiel Harbor, exactly where it had settled 24 years earlier. That hull did not stay buried forever. In 1887, 12 years after Bauer's death and 36 years after it sank, the Brandtaucher was finally raised from the floor of Kiel Harbor. What salvage crews recovered was not a footnote, was the physical proof of a story that had nearly been forgotten entirely, an iron hull that predated every other surviving submarine in the world by decades. Today, the Brandtaucher is preserved at the Bundeswehr Museum of Military History in Dresden, recognized as the oldest surviving submarine on Earth, a title that exists only because a design that failed catastrophically also happened to fail intact enough to be recovered and studied more than a century later. Recognition of Bauer's place in submarine history did not stop with a single museum piece. Nearly a century after the Brandtaucher sank, the West German Navy commissioned a Type 21 submarine and gave it a name that connected it directly back to the man who had built Germany's first. They called it the Wilhelm Bauer. It was a formal acknowledgement, long after the fact, that the low-ranking cavalry soldier with no engineering degree had been the starting point for everything that came after him in German submarine design, even if he had not lived to see any of it. 2 men, a century and a half ago, tried to solve the exact same problem from opposite sides of the ocean, using opposite philosophies, and history remembers them in almost opposite ways. Wilhelm Bauer built his submarine on subtraction. No ballast tanks, no engine, no complicated machinery that could fail at the one depth where failure meant death. Just a single sliding weight and a belief that gravity, handled correctly, was enough to conquer the sea. It was an idea elegant enough to work in a model the size of a shoebox, and fragile enough to nearly kill 3 men when a shrinking budget forced that same simplicity past its breaking point. Half a world away, the engineers who eventually produced the Hunley built toward a different kind of ambition entirely. A vessel designed from the start to do what Bauer's never got the chance to do. Find an enemy ship in open water and sink it. Where Bauer's story became defined by an escape, the Hunleys became defined by an attack. The first submarine in history to destroy a warship in combat, even at a cost that swallowed its own crew in the same encounter. 2 vessels, born from the same impossible question, and 2 entirely different answers to what a submarine was actually for. Bauer never got to test his philosophy in that way. The Brandtaucher never fired a shot, never approached an enemy hull, never accomplished the one mission it had been built and funded to carry out. Its entire legacy rests instead on 6 hours at the bottom of a harbor, on the ingenuity of 3 men who turned rising water into their only way out, and on a hull that happened to survive intact long enough to be pulled back into the light 36 years later. That is, in its own way, the truer measure of what Bauer actually proved. Not that his design was perfect. It clearly wasn't, and the men who cut its budget nearly paid for that mistake with 3 lives. What he proved was that the basic idea underneath it was sound enough to be worth trying again and again, in Russia, in Bavaria, in a Cold War-era submarine that would eventually carry his own name into service a century after he first sketched a vessel the size of a shoebox for a skeptical naval minister. A cavalry soldier with no engineering degree looked at a blockaded coastline and decided the ocean itself could be turned into a weapon. He was wrong about the details. He was wrong about the budget he'd need. Wrong about how thin his hull's walls could safely be. Wrong about how close his own invention would come to killing him on its very first public trial. He was not wrong about the idea. Somewhere at the bottom of a museum hall in Dresden, an iron hull with a crack in its side sits as proof of exactly how wrong, and exactly how right, one uncredentialed soldier could be at the same time.